Good day, everyone. Welcome to I Square Maths Academy, where numbers and variables actually meet mastery. In our last section, we actually looked at the application of the inverse matrix method in analyzing or solving solving simultaneous equations involving three variables. So today we are going to be looking at the determinant method, also known as the Cramer's rule. Yes, so we're going to be looking at how to use the Cramer's rule to solve simultaneous equation involving three variables. Let's get started. Now, looking at this, equation 1, we have x plus y plus z is equal to 6. Now, equation 2, we have 3x plus 2y minus z is equal to 4. And equation 3, we have 6x minus 5y plus 3z is equal to 5. Yes, in our last class on matrix method, that's the inverse matrix method, we actually designed those questions. Yes, so but today we are going to use the determinant method. Now remember I said that the determinant method and the Cramer's rule, they are the same thing. So if you're asked to use the determinant method or use the Cramer's rule, this is the method we want to use. So solution using the Cramer's. Yes, using the Cramer's rule. Yes, using the Cramer's rule. Now, the first step is to arrange the coefficients, just like we did in the case of inverse matrix method. Arranging the coefficients of x, y, and z, or the variables involved. So here, the coefficient of x is 1. Here we have 3. We have 6. Here we have 1. We have 2. Here we have minus 5. Here we have 1. We have minus 1. And we have 3. So here we have x, y, and z is equal to, we have 6, 4, and 5. Yes, 6, 4, and 5. Now, let's assign a variable to this matrix. Yes, let A be equal to matrix 1, 1, 1, 3, 2, minus 1, 6, minus 5, 3. Yes, let A be equal to this. Now, if A is equal to this, now let's see the determinant of A. Yes, the determinant of A. Now, the determinant of A will be the determinant of 1, 1, 1, 3, 2, minus 1, 6, minus 5, and 3. Yes. Now, let's use the Saros method. Yes, let's use the Saros method. Now, in using the Saros method, the Saros method, that is to find the determinant. Yes, using the Saros method. Now, when using the Saros method, remember I told us from inception that you have to repeat the first two columns. Yes, so it means the determinant of A will be equal to the determinant of, we have 1, 1, 1, we have 3, 2, minus 1, we have 6, minus 5, and 3. So you have to repeat those first two columns. So here we have 1, 1 again, 3, 2, then we have 6 and minus 5. Then at this point, you take the diagonals, three elements. If you look at this, the first diagonal here is just only 1. Here we have 2, so you take those first 3, you take the second 3, and you take this third one. Here it is just only 1, just 2 elements. So you take this, and you take this. Yes, you take this, and you take this. So in this case, the determinant of A will be, yes, you start with the principal diagonal. Yes, that's your left-hand diagonal. Yes, those way. That's the principal or the primary diagonal. So here we have it as 1 times 2 times 3. Yes, this one. Excuse me. Plus, here we have 1 times minus 1 times 6. Yes, plus, we have 1 times 3 times minus 5. Yes, then less the secondary or minor diagonal. Yes, so for the minor diagonal, we have it this way. 1 times 3 times 3 plus 1 times minus 1 times minus 5 plus 1 times 2 times 6. Yes, take notes. So it means the determinant of A will be equal to, so here we have 1 times 2 times 3, that will be 6. Yes, then plus, we have 1 times minus 1 times 6, that's minus 6. Then here we have plus 1 times 3 times minus 5, that's minus 15. Then here we have minus. Here we have 1 times 3 times 3, that's 9. Minus times minus is plus. So 1 times 5, that will give us plus 5. Yes, plus 5. This is 9. And this is plus 5. Then here we have plus 12. So it means the determinant of A will be equal to, now this 6 will go with this 6. So here we'll be left with minus 15. Yes, minus. Here we have this plus this is 14. 14 plus 12. That's 26. So here we have 26. That is minus 26. Yes. So it means the determinant of A will be equal to minus 41. Yes. So take note of this. Yes. The determinant is minus 41. Okay, now let's see the determinant of X. Yes. So determinant of X now will be equal to the determinant of, now since X is the first variable here, this will actually take the first position here. Here's the first column. So here we have 6, 4, 5. 6, 4, 5. Then here we have 1, 2, minus 5. We have 1, minus 3, and 3. Okay, 1 minus 1 and 3. Yes. So now we can see here now that this column here has actually taken the position of this first column. Yes, because we are finding the determinant of X. So now let's use the Cyrus method. Yes, I want us to get used to the Cyrus method. So it means in using the Cyrus method, we said we have to repeat the first two columns. Yes, that is the first two columns. So here we have 6, 1, 1, 4, 2, minus 1, 5, minus 5, 3. Yes, 5 minus 5, 3. So here we have 6, 1. We have 4, 2. We have 5 minus 5. Yes. So now you're taking 3, 3. That's the diagonal. So this is just 1. Here we have 2 elements. So here you have 3, 3, 3. Here we have 3, 3, and 3. Okay. So the determinant of X will be equal to, okay. So here we have 6 times 2 times 3. Yes, 6 times 2 times 3. Then we have plus 1 times minus 1 times 5. I'm taking it this way. Yes. Yes. So here we have plus. We have 1 times minus 1 times. Okay, we've done that. 1 times minus 1 times 5. Now we have 1 times 4 times minus 5. Yes, the whole of this less. Yes, minus. Now the minor diagonal. So here we have 1 times 4 times 3 plus we have 6 times minus 1 times minus 5 plus we have 1 times 2 times 5. Yes, 1 times 2 times 5. So it means the determinant of X will be equal to, so here we have, this is 2 times this, 12 times 3, that's 36 plus, now this will change to minus because of this minus sign. 1 times 1 times 5, that will be minus 5. Then because of this minus sign, we have minus 20 there. Yes, because 1 times 4 is 4. 4 times minus 5 is minus 20. Now the whole of this, yes, minus. Then we come down. Here we have 1 times 4 is 4. 4 times 3 is 12. So we have 12 plus, this is 6 times minus 1, which is minus 6. Minus 6 times minus 5 is minus 30, is plus 30, because minus times minus is plus. So here we have 30. Then here we have plus 1 times 2 times 5. That will give us 10. So it means the determinant of X, will be equal to, so 36 minus 5 is 31. 31 minus 20 is 11. So we have 11 minus this, 12 plus this is 52. Yeah, is 42. 42 plus 10 is 52. So it means the determinant of X will be equal to minus 41. Now let's take note of this. Yes, the determinant of X is minus 41. Now let's look at the determinant of Y. The determinant of Y. Now the determinant of Y, this Y is the second variable here. Yeah, so because Y is the second variable, it means this column here, this matrix will take the position of the middle one, because Y is at the middle here. Yeah, so this will take this position. So we have 136. 136. Yes, 136. We have 6, 4, 5. Yes, we have 6, 4, 5. Then we have 1 minus 1, 3. 1 minus 1. Then here we have 3. So to find its determinant, now I want us to repeat the Cyrus method. Yes, I want us to get used to the Cyrus method. Remember, I told us that you cannot use the Cyrus method beyond 3 by 3 matrix. Yes, it's actually constricted to 3 by 3 matrix. Yes, so here we have 1, 3, 6. We have 6, 4, 5. We have 1 minus 1, 3. Then you repeat the first two columns. We have 1, 6. We have 3, 4. And we have 6, 5. Yes. So now you start taking the three elements. Yes. In the both diagonals. So for the principal diagonal, we have 3. Here we have 3. And here we have 3. Now for the minor diagonal, this is just 1. This is just 2. So here we have the first 3. We have 3. And here we have 3. Yes. So it means the determinant of y will be equal to, now let's start with this. So this is 1 times 4 times 3. Yes, 1 times 4 times 3 plus, we have 6 times minus 1 times 6. Then we have plus 1 times 3 times 5. Yes, the whole of this. Then less this one. That is the minor diagonal. So here we have 6. We have 6 times 3 times 3. Yes, plus, here we have 1 times minus 1 times 5. Yes, then here we have plus 1 times 4 times 6. Yes, 1 times 4 times 6. So it means the determinant of y, will be equal to, so here we have 1 times 4 times 3, that's 12. So we have 12 plus 6 times minus 1 times 6. That's minus 36. So this will change to minus 36. Then here we have plus 1 times 3 times 5. That's 15. Yeah, so we have minus. Now 3 times 6 times 6. That's 6 times 9. Yes, and 6 times 9 is 54. So here we have 54. Yes, 54. Then minus. We have 1 times minus 1 times 5. That's 5. Then we have plus 1 times 4 times 6. 1 times 4 times 6, that's 24. So here we have 24. So it means the determinant of y will be equal to, now let's look at 12 plus 15. That's 27. Yes, 27 minus 36. Yes, there is 16 minus 7. That's 9. Yes, that's 9. That's 9. So here we have this plus this is 27. 27 minus, that's minus 9. Then we have minus 54 minus 5, that's 49. And 49 plus 24, this will be 3. Yes, that will be 73. So minus 73. So determinant of y will be equal to minus 9 minus 73, which is minus 82. Yes, that's minus 82. So it means the determinant of y is equal to minus 82. Please, let's take note of this again. Yes, let's take note of that. Yes, so now let's see the determinant of z. Yes, the determinant of z. So the determinant of z, now z is the last variable here. Yes, z is the last variable here. And because z is the last variable, so this will actually take this last position. Yes, so it means we have 1, we have 1, 1, 1, yes, 3, 2, 3, 2, 6 minus 5. Yes, 6 minus 5. Then 6, 4, 5. 6, 4, 5. So since we are calculating for determinant, we're going to repeat the first two columns. We have 1, 1. We have 3, 2. And we have 6 minus 5. Yes. So this method is called the Cyrus method. Yes, so you take the three elements from the diagonal. We have 3. We have 3. And here we have 3. Here we have 3. We have 3. And here we have 3. It means the whole of this now will be equal to, the determinant of z will be equal to, we have 1 times 2 times 5 plus 1 times 4 times 6 plus, we have 6 times 3 times minus 5. Yes, the whole of this less, we have 1 times 3 times 5 plus 1 times 4 times minus 5 plus 6 times 6 times 2 times 6. 6 times 2 times 6. Yes, please take note. This is 6 times 2 times 6. So it means here the determinant now will be equal to, yes, the determinant, now let me use a space. Yes, the determinant of Z will be equal to, the determinant of Z will be equal to, we have 1 times 2 times 5, that's 10. So there we have 10. Yes, we have 10. We have 1 times 4 times 6, that's 24. So here we have plus 24. Then here we have 6 times 3 times minus 5. Yes, minus 5. So 6 times 3 is 18 times 5. This is 40. And that will be 90. So here we have minus 90. Then minus. Yes, minus. Now let's look at this. 1 times 3 times 5. That's 15. So here we have 15. Yes, 15. This is 1 times 4 times minus 5. That's minus 20. Minus 20. And here we have 6 times 2 times 6. That's 12 times 6. This is 72. Yes, 72. So here we have plus 72. Yes, plus 72. So now it means in this case, the determinant of Z will be equal to, now this plus this. 10 plus 24 is 34. Yes, 34 minus 90. Let's see 90 minus 34. This is 10, that's 6, remaining 8. 8 minus 3 is 5. So here we have minus 56. Yes, minus 56. Then here we have minus. Yes, we have minus. Now let's look at this. 15 minus 20 is minus 5. Minus 5 plus 72. 72 minus 5. This is 12 minus that's 7. That's 67. So here we have minus 60. Sorry, this is plus. So that will give us plus 67. So it means the determinant of Z will be equal to minus 56 minus 67. Yes, we're just saying minus 56 plus 67. So the determinant of Z will be equal to, now let's look at 56 plus 67. Yes, that will be 123. Yes. Yes, 123. So that will give us minus 123. Now let's also take note of this. Yes, let's take note of this. Now we have seen the determinant of X, the determinant of Y, and of course the determinant of Z. So let's get the value of X now. So the value of our X is the determinant of X all over the determinant of A. Remember, A is overall determinant. That's where we started from. The determinant of the main matrix. So the determinant of X, we got minus 41. So minus 41 all over. Determinant of A, we got minus 41. So minus minus is plus. So 41 divided by 41 is 1. Now let's see the value of Y. So that will be determinant of Y all over the overall determinant. So determinant of Y, we actually got minus 82. So here we have minus 82 all over minus 41. So minus minus is plus. So 82 divided by 41 is equal to 2. Now let's see the value of Z. Our Z is the determinant of Z all over the overall determinant. And the determinant of Z actually gave us minus 123. So we have minus 123 all over minus 41. So minus minus is plus, and that will give us 3. Yes, that will give us 3. So therefore, yes. So therefore, yes, so therefore, our X is equal to 1, Y is equal to 2, and Z is equal to 3. Yes, so these are the values of the variables. Yes, X, Y, and Z. So this method is actually referred to as the Cramer's rule or the determinant method. So thank you so much for listening. Watch out for the next video on the Gaussian elimination method. So remember to like, share with your friends if you actually enjoyed the video, and subscribe. God bless you.